This is the Synthetic Signal Report for Monday, July 13th, 2026, in the morning. Today we track a surge in critical web application vulnerabilities, the increasing strain of artificial intelligence data centers on energy infrastructure, warnings regarding the 2027 memory supply crunch, and a new research paper on monolithic optomechanical photonics. The security landscape is currently strained by a wave of high-severity vulnerabilities affecting popular WordPress and web management tools. Researchers have identified critical deserialization flaws in Kirky that allow for arbitrary object injection. Separate issues include stored cross-site scripting in the TagDiv Composer and Cloud Library suites, and blind SQL injection vulnerabilities within the AC mailing newsletter system. These vulnerabilities, many carrying high severity scores, underscore a persistent weakness in the plugin ecosystem, where improper input neutralization and flawed authorization checks remain common. Administrators must prioritize auditing these specific components, as the prevalence of these flaws provides attackers with reliable entry points for site-wide compromise. Microsoft's latest environmental report reveals a 25% increase in greenhouse gas emissions over the last year. This sharp rise is attributed directly to the massive scale of data center construction required to support generative artificial intelligence. Simultaneously, SK Hynix has issued a stark warning. The memory industry is heading toward its worst ever supply shortage by 2027. The demand for high-bandwidth memory, driven by large-scale artificial intelligence training clusters, is expected to outstrip supply well beyond 2030. This creates a volatile feedback loop where the rush to expand compute capacity is simultaneously driving environmental costs and physical component scarcity, signaling that current growth trajectories for artificial intelligence may face hard physical ceilings. A collaborative research effort involving MITRE, the University of Colorado Boulder, and Sandia National Laboratories has demonstrated a fully monolithic, all-CMOS fabricated platform for piezo-optomechanical photonic integrated circuits. This is a signal from the future because it moves beyond traditional electronic processing by integrating mechanical and optical components directly into the silicon manufacturing process. By enabling these circuits to operate on a standard production line, the technology provides a path to high-speed, low-power interconnects that could eventually bypass the thermal and energy limitations of copper-based signal transmission, currently throttling AI data centers. Community chatter is hyper-focused on the following developments. First, there is significant pushback against AI coding assistants. Empirical analysis shows that Claude Code and similar agents consume massive token overhead, up to 33,000 tokens, before even reading a user's prompt. Developers are questioning the efficiency and cost transparency of these agentic tools. Second, the security community is tracking a China Nexus threat actor identified as UAT7810. This group is actively expanding its network of orb router malware, deploying sophisticated new payloads named Longleash, Dogleash, and Jarleash to maintain persistence within enterprise infrastructure. Third, the community is debating a new research paper on latent reward steering, an inference time framework that allows developers to dynamically steer the cognitive behaviors of reasoning models. By adjusting reward signals during the generation process, rather than through static training, this method provides a more adaptive approach to correcting reasoning failures in real time. Finally, while no new automated tools appeared on the GitHub trending list today, there is a clear trend toward deterministic networking. Researchers are actively exploring the eSUN architecture, which aims to evolve Ethernet into a lossless, low-latency transport protocol specifically engineered for the high-bandwidth requirements of artificial intelligence accelerator clusters.